On to FitCo, the third of the Section B questions. We can see instantly we've got a variance calculation, material mix variance, and total yield variance, material usage variance. This one initially looks like an outlier, but I'm less keen because it's stating some facts. The total price variance is favourable. I'm not sure if it is. So I would leave this one and do this as part of the normal process. Whereas this one is more generic. I can see select whether each of the following statements is or are correct. Ideal standards are short-term targets and useful for day-to-day control of operations. Ideal standards are not achievable. So comparing performance against something that's not achievable means every variance would be adverse. It would demotivate and is not a good way to set targets or measure performance. Variance analysis is suitable in companies operating in a modern manufacturing environment. Variance analysis is more linked to traditional manufacturing processes. In modern manufacturing, you get a lot of customization, single orders, that sort of thing, so that is less likely to be correct. So we've only got one outlier in this question. It's very rare for there to be none. We did have 3 in one of them, so that's also quite rare. Okay, so we'll make a start on the variance calculations. But as before, if you pause now, read through the information on the question stem. So in this question, we need to find the material mix variance. And in the next question, although it doesn't say, given the information, it must mean the material yield variance. Mix and yield variances are obviously part of a little group of material usage variance. And I would certainly recommend having a process, having a template that you can use and apply for mix and yield variances. And you'll see in the scratch pad I've put 26 and 27 together because there's an efficiency in working both together. I've also written flex. One of the areas where students get stuck is they forget to flex the budget. So remember, the cost card is based on one product. So we need to flex this based on actual production in order to make it a useful comparison. And this is what I do, is I look for what I call the actual quantity at the actual ratio. That's what actually happened. And I compare to the actual quantity at the standard ratio. Some people use the term mix instead of ratio. And the difference between those helps me get my mix variance. And the difference between the actual quantity at the standard ratio and the standard quantity at the standard ratio, that's the flexed budget, gives me my yield variance. I write this out more for the reasons of tuition, not for us to actually do in the exam. So this is the template I use for doing the mix variance. So I've got the 3 parts that are put in, the 3 ingredients, cereal, glucose, protein, got a line for my total, and I'm looking to compare these two, the actual quantity at the actual ratio with the actual quantity at the standard ratio. And then we go hunting for the information. I start with actual quantity, actual ratio, and that's what we actually did. And that's the information given to us here. We put 380, 127 and 100 in. And then when we total those up, we put 607 kilograms in total. And now what we need to do is take that 607 kilograms and work out what it would have looked like had we used the standard ratio, which is given to us here, where they put in 30 grams of this to 12 of this to 8 of this. And I put this here just for information. For every 30 grams or kilograms, we put in 12 of glucose, 8 of protein, and it totals 50. So in order to work out our column here, we take the 607, we divide by 50, and we multiply the result by 30, and then we do the same again multiplying by 12, and the same again multiplying by 8. So 12.14 multiplied by 30 means if we'd stuck to our standard ratio, would have used 364.2, and for G would have used 145.68, and for P would have used 97.12. And now we find the difference between this column and this column, and we need to be consistent. So I would do first column and subtract the second column. What's important in a mix variance is that the total of these should be 0, because we wouldn't expect any difference because we're just comparing the ratio of inputs, not the total input compared to the total output. We're still working in kilograms, so now we need to multiply by the cost per kilogram, which we take from our standard cost card. The variance is just simply multiplying those together. I've just rounded these through to bring them to one decimal place just to be consistent. And the total variance is 56. Now in terms of is it adverse or favourable, I prefer to work it out. So we're looking at a material mix variance. The materials is an expenditure. So on this line we actually used more than we expected to, so that would be adverse. In this line we used less than we expected to, so that would be favourable. This one we used more, that's adverse. Keeping the sign consistent, that would also be adverse. So 56 adverse is our answer here. And for my yield variance, I've copied and pasted this because I'm going to reuse some of it. So AQSR is reused, that's this one, but now we need SQSR. So I replace the first column with the standard quantity at the standard ratio. And this is where I flex my budget. I take the standard cost card where it uses 30 grams for 1 unit and we made 11,200. And then I need to divide that by 1,000 to bring it into kilograms, so I end up with 336. Next we used 12 grams of syrup. I'm just going to be efficient, multiply by 11.2 because then that divides by 1,000 as part of the process. That goes to 134.4, and then 8 lots of 11.2 is 89.6. So now we've got our actual quantity at our standard ratio of 607. Our standard at our standard is 560. So we used more than we expected to use because the actual compared to the standard. So therefore it has to be an adverse variance. If you're running out of time at this point, you could guess one of those two. Standard ratio we don't need for this calculation because we used it in the stage above to do this. So we next do the differences, subtracting one from the other. Of note, the difference is irrelevant here when we total it because if it's adverse, they'll all be adverse. The costs are the same, so now I'm just multiplying that. I've already decided it's adverse as I said earlier. So when we total those three together, we end up with 376 adverse. Key takeaways: make sure you have some sort of template for mix and yield variances that you can remember and you can produce quickly and efficiently, either in the scratch pad or in the spreadsheet if it's a section C question, and then use that to help go and find the information and pull it into here. The push approach where you read through this and try and work out what do I need tends to be harder to do and you're more likely to make a mistake. So template that you've tried and tested that you can reproduce in the exam, and don't forget to flex based on actual production. And for material variances, make sure you're using the standard cost per kilogram, not the actual cost per kilogram. What is the total adverse material usage variance? Well, if we add together our mix and yield variances, the 56 and the 376, that gives us 432. So we save a bit of time on that one. The other way to do it is to take the actual quantity and the actual ratio, subtract the standard quantity at the standard ratio, find the difference between those two, and then multiply by the cost per kilogram to get the variance. Okay, select whether the following statements is or are correct. The procurement manager performed well because the total price variance is favourable. Well, let's look at the price variance. The price per kilogram for cereal should have been 10 and was 11.2. For glucose should have been 6, was 6.5. For protein should have been 3.5, was 3.6. As all three are higher, then that means it isn't favourable, it's adverse. So that's incorrect. The mix variance indicates that the actual output was lower than expected despite the use of more premium ingredients. Mix variances are nothing to do with output, they're to do with the ratio of inputs. When we compare the ratio of inputs and our standard compared to what we actually did. For an adverse mix variance, you have more of a more expensive input and less of a less expensive input. So it's nothing to do with output, so that is also incorrect. And that's the end of this section B question. Thanks for listening.